Greetings everyone and welcome to your definitive guide to Git and GitHub. First thing that I want to say is why I want to tell you why I am recording this video. Okay, so there are definitely tons of videos already available that discuss what is Git and what is GitHub, and they're good videos. But the only thing that I feel that they lack is that those videos are designed to get things done. Those videos are designed to teach you how to go from point A to point B, how to do a very specific task. I'm not saying that they're bad, they are definitely good. I have watched them too. But what I personally feel is that as a developer and a software developer and as an engineer, you should know that uh, why you are doing what you're doing and how things are happening that are happening. The core depth, or at least have a little background that okay, I'm doing this and this is the reason why I'm doing. Don't just go like blind into it. Okay, how do I do the specific task X? I googled it, I found a solution, and I did it. And I have now just like memorized the steps, and that's how I'm going to proceed ahead. Um, it's going to work out for you in most cases, but once you come across a problem, your problem solving skills in a technical environment are reduced by a lot. So this video is in the same light. We will be talking about Git versus GitHub, and we are also going to talk about version controlling, and then we will talk about a nomenclature of Git and GitHub. Then we'll create a repository. We will connect our project to our repository, and next we will talk about staging, commits, and push and pull requests. Final major topics will be branches, pull request, and issues, and cherry on the cake would be talking about GitHub Pages, right? So without any further ado, without wasting much more time, let's get started. So the first thing that you need, the prerequisite, is a GitHub account. I suppose that you all have a GitHub account already. If you don't, you can make one. It's very easy. And the next thing that you need is Git installed on your computer. Git, that's how you spell it, and you can search Git on Google or whatever search engine you use. Go on to git-scm.com and just download it with a version for your operating system. If you're on Windows, that's how you do it. um, you just go to this downloads section, pick your operating system Windows, and download it and install it. I'm not going to go over how you install Git on Windows, of course, but if you are on Linux, what you can do is you can use the simple command sudo apt install uh, Git. That's as easy as it gets, and then you can enter your sudo password. Since I already have installed GitHub on my system, I don't have to install it again. Anyway, with that out of the way, now we have fulfilled the two prerequisites that we were supposed to. The first thing that we need to understand is the difference between Git and Git and GitHub. I'm sorry. Okay, this is GitHub, right? You can understand it, GitHub. Anyway, so Git that we have here is a technology, and GitHub is a service that enables you to use this specific technology. If you go back in time when they were creating Linux, the people who were creating Linux were facing a problem. Okay, let's just say that you are working on a software, and the software is called Project X. It's a top secret project, and it's going to save the human race from a zombie apocalypse or something like that. I don't know. Anyway, so you are A, and you are working on this top secret project X. Now, you are a developer, right? And you introduce some very nice new changes to your project. Let's call these changes Z. So you introduced Z changes to your project, and now your project's current state is XZ, right? But now you quickly realize that the changes that you made, the Z changes that you made to your project, are causing a lot of problems in solving existing ones. They're creating more problems in solving existing ones. So you decide that I need to go back to my previous state, to before the Z changes were introduced. Now it becomes a hassle for you because you don't know because you introduced a lot of changes to your project. You created a lot of dependencies. You made changes to your existing code here to the project X code in order to introduce the Z change. And it becomes very, very difficult for you to roll back your changes. So you came up with an idea that what if I save a copy of project X somewhere else here, and then I'll introduce changes, Z changes. If they work out, yes, it's great. Then I'll move ahead, and then I'll save another copy of this project XZ somewhere to keep it safe, that this is a stable release of my project, this is a stable release of my software, right? But if it doesn't work out, what I can do is I can go back here, the project X, the copy that I created earlier, and I can work again, and then I can push new changes, the Z bar changes, and if it works out, I can create a copy XZ, a new copy of it which is stable. If it works out, yes, then I'll create a new copy. If no, then what? What I'll do? I have messed up my second copy, which was the stable release of the project. What I'll do is, again, I could have created another copy of X, and which could be project X bar, and then X bar, double bar, X triple bar, and it's a very, it's tedious task to create copies of your project and copies of your project at every single point. What if we automate this project, or automate this project, and automate this entire process? Git solves the very same problem. What Git does is it monitors is a very important word. It monitors all the files that you have in your project. So if I have two files, let's just call them XYZ in my project, project X, I have these three files. Git is going to monitor all these three files, and it's going to check what changes are being made. So let's just say that this is the stable version of my software right now. This is the stable version. So I'm going to tell Git that, hey bro, this is the stable version, and I'm very much satisfied with the code that I have here, and I want you to click a snapshot of it, right? Create a copy of it and save it somewhere. So that's exactly what Git is going to do. It's going to save a snapshot or a copy of this somewhere without taking a lot of disk space and your system resources, and then you can continue your work like you would. Unlike here, where we had so many different pathways that I can either go here, I can either go here, I can come back to like my project X, copy of my project X if it didn't work out, or if it did work out, I can create a fresh copy of XZ as a stable release, and then I can move ahead from here. And it's a very complicated pathway. But now it's very much linear. I have Git, I work on my project, it's monitoring all my files, it's created a snapshot here, it's stable. I introduced like bad changes to my software, and I said that, hey, wait, hold on, I have messed up big time, let's go back. So Git is going to go back pretending that this thing never existed, right? It never existed, and we can go back to a previous state, and then we can start working on a new version which is probably going to work, hopefully, and it does, and we can move ahead, and it just moves on in a single line, linear, very much linear, and it solves a lot of problems for us. Now that we have Git out of the way, now we know what exactly Git is doing. We need to understand what is GitHub. Now GitHub is a service. uh, Git is essentially a technology that you have to install on your computer, that you have to install on your machine, which is going to monitor everything. It's just like installing Adobe Photoshop. It's just like installing Adobe Animate or Microsoft PowerPoint or anything as such, right? But GitHub, on the other hand, it's a service. It's a website that enables you to comfortably use the technology Git is based on. So we have GitHub, we have our account. Why exactly are we doing this? Why exactly are we doing this? Why do we had the need to go back to previous state? This is called version controlling. Right now, I am working on my project. What if two, three, maybe 20 people, maybe 50 people are working on the same project, and they are all working on different things. Maybe someone is working on the front end, someone is working on the back end, and even the front end, someone is working on maybe on the login page, and someone else is working on, I don't know, the home page or anything as such. um, how do all these people coordinate properly? How do you merge the code that these guys are writing properly and effectively? How do you make sure that if you have missed a big time, you have to go back and to the stable release of your product, of your software, and start over again? This is version controlling. This is very essential in software development, even if you are a single person or even if you are working with big teams and so on and so forth. Version controlling is very important and it's essential. You are essentially controlling the version of your software. Now, GitHub not just allows you to version control your software. It's a lot more than it's a lot more than just like enabling you to version control your software at this point, because there are so many features that GitHub provides, and covering them in one video would be too much to ask for. But we will go over the basics, and of course, that's what we're going to do. Now, the nomenclature of GitHub. First of all, we need to understand what is a repository. A repository is basically a place that where you are storing your code, where you are storing all the information related to your project. Consider it as a box that has all the contents of your product or of your project. We create repositories on GitHub, and when we create repositories, we are essentially creating a box, and then we can put all the stuff that we want to put in, that is associated with our project, our code, our images, assets, libraries, and everything. Now, next thing that we need to know is what exactly do we mean by staging. Now, we will come to this later on, don't worry. And we have commits. In a relationship, we say that, hey, I'm committed to this relationship, I am committed to this task. Same thing happens here in GitHub. If we go back to our linear version here, that at this point I said that, hey, GitHub, I am satisfied with the current state of my project and I can commit this. I am committed to this. What I want you to do is create a snapshot of it. How do you create a snapshot? I have to tell GitHub that, okay, you can commit this change and save it as a snapshot, and GitHub does it. And Git does it for us. It commits those changes, it creates a snapshot and saves it to a safe place, and so that we can move ahead. And if we mess up sometime in the future, we can come back to the snapshot because it was committed. We ourselves told Git that, hey, save it. Anyway, another thing that we need to know about is push and pull. You might would have heard, if you have like worked in a professional environment or with a team, that they always say that, hey, push the code or maybe pull the code. For this file, just understand that pushing the code is uploading and pulling the code is downloading. Next, the three terms that are there that you need to know about is branches, pull requests, and issues. We'll talk about them when we'll discuss them individually. Now, the first task that we have is creating a repository. Like I said, repository is basically a box which is going to store all of our code and everything that we have here. So we can start off by creating a repository. Open up github.com. You'll be presented with this nice home screen. It might look different for you. Anyway, so you have two options, two ways to create your repository. You can either use the navbar here on the top right corner. You can use the plus sign and then you can create a new repository. Or if you already have some, you'll have this sidebar and you'll have an option to create a new repository. They both will take you to the same page. There's no difference between these two. So click on that plus sign and create a new repository, and it will take you here on this page. It will ask you to create a new repository. So let's create a new repository. I'll just call it Unga Bunga. Sorry. Now, I've created a new repository. like I've given it a name, and now we are given the option that do you want to add a description to it. Yes, I want to add a description. This is my description. So the next option that we are presented with is the option to make the repository public or private, right? Public, they're pretty much though self-explanatory, but let's just go over them once again. Um, because why not? Now, public repository is the box which everyone can see and everyone can look into that what exactly is inside the box. But then there is sometimes there are private stuff. There's probably something you don't want the world to see. Maybe something that's very dear to you and you want to keep it safe and secret. So you can create the repository as private so that no one can see that box even, let alone see what's inside that box. But we don't want to do that, right? So we're going to create a public repository. We will talk about the readme file, the gitignore file, and the license file later on in this video. So we are not concerned with the other three options. Let's just click on the green button which says create repository. Once you do that, you will be presented with this screen which shows you a lot of cryptic stuff and so on. So we're going to use these instructions only to connect. These are basically the instructions that are telling you how you can connect your project to this GitHub repository, which we're going to do that. For that, we need to create a project on our local machine, which we will connect later on with our repository, right? So I'm going to create a directory here, and let's call it Oonga Boonga. You can name it whatever you want, but for the ease or just to make keep a singularity here. So let's go to our folder that we have created, Oonga Boonga, and I'm going to create some files here. I'm going to create, and I'm going to create, these are just random files, they don't have any meaning or so. So let's open them in our code editor. Right, we have a Visual Studio Code here, it's loading. So we have a lib.c++ and main.c+, and they are essentially two empty files. So I'm just quickly going to add some content here to these files. Great. Just like your basic standard code. Um, right. So now we have our basic code here. What is this? Don't ignore it. I'll just quickly copy the same code to lib.c++. Let's just say that lib.cpp is a very important dependency to that to our main.cpp file, right? And let's just like make changes here. Okay, so now we have our software ready, which is going to save humanity from, I don't know, some apocalyptic event, right? How do we tell? How do we like monitor these two files that we have here, lib.cpp and main.cpp? How do we keep a check on these two files? So for that, we need to initialize this folder, the folder that we created, Oonga Boonga here. we need to we need to initialize this folder as a Git repository. We are not connecting it right now, but we are going to initialize this as a Git repository so that Git can monitor and keep a check on all the files that are present inside our folder. So how do we do that? So the easy way to do it is you go to your terminal. Okay, so if you are on Windows, what you are supposed to do is open your file explorer, open this folder that you have, double click on the folder, you'll see these two files, right click on it, and after you have installed GitHub, you will have two options in your right click menu. One is going to be git bash here, and another is going to be git GUI here. Open git bash here, and then you can follow the same commands that we are writing here, that I am writing here. So First of all, we need to initialize this folder as a Git repository. How do we do that? We use the command git init. Now, I would recommend that all the commands that we are using right now, you could just write it down on a piece of paper if you're not used to them already, on a stick note, and put it up somewhere where you can see everywhere, every day when you're working and when you're doing stuff, right, on the computer, so that you know, okay, this is a command, don't forget it, because you need to memorize this. And with time that you will learn it, but you just like need to know these commands. So first of all, git init. This is going to tell that hey, the technology we are using right now is Git, and we're telling Git to initialize this repository as a Git repository. Just press enter, and it's going to give you some output. And the last output should be initialized empty Git repository in home doomketu desktop boonga.git. It has created a Git folder. If you go here, we don't see a Git folder because it's hidden. But if I do view the hidden files, I'll see a folder called .git, and it has everything that Git needs to monitor with these two files. We have absolutely no business with these two files, so we're just going to go back and we're just going to hide it again. And we have initialized it with initialize a folder as a Git repository, right? Next thing that we need to do is we need to stage the changes, stage the files that we have here for our commit. Now, you would have noticed in our Visual Studio Code, the moment that I clicked, that I initialized this repository as a Git repo, all these files got this U symbol in front of them. The reason why we have this U symbol here, because it means untracked. These files are not being tracked right now. Even though we have initialized the repository as a Git repo, we need to tell Git what files that we want to track. How do we do that? Again, we need to specify the app that we want to use. We want to use Git again, right? And now we need to track these files. So we need to add these files to the tracker. How do we do that? We use the command add, and then how many files do I want to use? I want to use both lib.cpp and main.cpp. So I could essentially go on and type their names individually, lib.cpp and main.cpp, but it's stupid because when I have a lot of files, let's just say I have 20 files here and I want to track all of them, I can just use a dot instead, git add dot, and then press enter. Now you would have noticed that, wait, you wouldn't have noticed yet. Now the other command that we need to use is, or need to keep a check off, is the git status. We can use this command and it's going to give us some output. It says that no commits yet on the branch master. We'll talk about this later on. Now changes to be committed. The two files are ready to be for the commit, and but these files are just staged. New file lib.cpp and new file main.cpp. Okay, so we are now tracking our two files, but these are not ready for the commit, because remember I told you here that we need to tell Git that hey bro, I am absolutely fine with the current status of the project and I want you to take a snapshot of the current status that we have. How do we do that? The simple command for this is, again, we are using Git and we tell that commit these changes, bro. I'm satisfied, commit these changes. But before that, since it is your first time we are creating this, what we need to do is, should we do it? Wait, we should not do it yet. We'll talk about this later on in the video. So let's create a commit. Let's commit these changes. Now with every commit there goes a message, which is essential, and the way to add a message is you write -m, and in the double quotes anything that you write is going to go as a message. It is to clarify that what exactly have you done. So I have created two files here. So I have created lib.cpp and main.cpp, just to be clear what exactly am I committing and what exactly is this, does this commit hold. And I press enter. It's going to give me some output that two files have been changed, 16 new insertions, 16 new insertions essentially mean that 8 lines of code in both the files. That means 16 new insertions have been made. And now we need to specify the branch that we want to push the code in. Go back to your GitHub web page. You'll have this create a new repository on the command line, right? Now we are here. We have committed the changes. We have initialized our repository, and we have added all the files to, like, we have staged all the files that we created. Now the next step is to create, like, to make sure that what branch are we pushing to. We are pushing to the main branch, right? So you could either just like copy this one, get branch -m main, or just go on get branch capital M and main. Main here is the name of the branch, and we will talk about branches later on, because I can, if I'll go explaining to you right now, it will confuse you a lot. So just press enter, and it's going to specify here that you are pushing the code to the main branch. Now the final step would be to actually connect the repository that you created on GitHub to the one that you have physically available on your machine here. So it says that the way to do it is by git remote add origin boonga.git. So if I paste this command here, let's go over this command. It's a little long, so I'm not going to type it. Git, we're specifying that we're using the technology Git, and then we are adding what's the remote, like where exactly are we doing, where exactly is the origin of it, and then we are telling that, hey, add the origin. There was no origin yet, but we are adding the origin now. What exactly is the origin? Origin is the URL of a repository which ends with .git always, and then we press enter. We have added the origin. Now our project, which is physically created on this system, on this machine, is now essentially connected to this repository right here. So how do I upload the code that I wrote on my physical machine to my GitHub repository? It's very easy. Again, the final command is to push the code git push -u, as it says here, origin main. You won't have to use -u origin main always. You just have to use git push. Later on we'll have a look at it, but for the first time we need to do it. Press enter. It's going to push the code. As it has done, it is going to give you some output. Let's quickly refresh our page here, and you can see magically it shows lib.cpp and main.cpp are present in our repository. And we also have a message that I have created lib.cpp and main.cpp. This is the same message that we added on our command line on our terminal, and it says that it was done 3 minutes ago. So the timestamp is always of the time than when you actually commit your changes. Also, when we were creating the repository, it asks just for a description. The description always comes here, confused Junga Bunga. That's what I wrote. So that's my description. Now, we know about that we need to stage our files. We know about we need to commit them, and then we know that we need to push the changes. But that's not the true essence of GitHub. If you're putting anything on GitHub, you either have two objectives. First objective is either you want to work with the open source community and you want to put your code out there, and the second objective that you might have is that GitHub is a nice place to store your code and your projects and host your projects. So if you want to show your project and your source code to someone somewhere else, you're not always gonna carry your laptop and your machine everywhere. So GitHub is a good place to start. You can just always open up github.com and show them your project, and that's a very nice way. It's basically like cloud computing. Now that we have it, we have uploaded those two files. Let's go back and analyze the first reason that for using GitHub. The first reason that I stated was that you want to go out and work in the open source community and put your code out there to the people and help them. What exactly is open source? I suppose that you guys are aware, but if you are not, open source basically means that you the whatever you are coding, whatever project you're working on, the source code of that project is available for people to view, to modify, and to use that same thing, and like I said, modify and create something new out of it. With that out of the way, let's open source communities are built when a lot of people collaborate on the same project. Right now on this project, only one person is working, and that's me. Let's just say I want to add another person to this project. So I can click on settings, then I can go to manage access in my side panel. I can confirm my password, and then I can add a collaborator. I can click on invite a collaborator, and then I can search their username and invite them. Um, that's how easy it is, right? But that's not how most of the repositories on GitHub works, because you're not going to add, because repositories on GitHub, the great big projects that are available on GitHub like React, Angular, they have thousands of people who are contributing to that project. They're not going to add each and every one as a collaborator. They're not going to give admin access to each and every one of them. What if someone just one day decides that, hey, I don't like Angular and I'm going to delete this repository? So we don't want to do that. How do those people work on the same project? That's where the concept of the true essence of GitHub comes in, and the true essence and the true potential of GitHub comes in, and Git and GitHub. We are first of all going to talk about branches. Now, branches, let's go back to our whiteboard and understand what branches are. So let's just say there's a person A, which is me, and there's this person B, which is you. You are a backend developer, and I am a front-end developer. Right? We are both working on our top secret project, Project X, and I'm going to work on the front end, and you're going to work on the back end. So you are working on the back end. Let's say XB. You have the XB version of the project, which has the back end, and I have the XF version of the project, which has the front end. Essentially, now our objective is to merge these two versions of, or two states of a project together, so that they can work in harmony, and we can have the project state XF, which has both front end and the back end, and both are working in harmony with each other, and we have a new stable state of our project. If you're doing it manually, if you're going to do it manually, it's going to be very hard, because you'll have to be in constant touch with each other. I mean, even though if you're working on GitHub, you have to be in constant touch, and at least let the other guy know that, hey, I'm doing this, and the front end guy can tell and confirm that, okay, I'll work accordingly. But to merge our code and to make our lives a lot easier, GitHub provides us with features like branches and merging and pull requests, etc. So what we did was basically we created two branches here, right? One branch is for front end, one branch is for back end. Or maybe we can understand it in a different way, in a better way. Let's say that we have a project, same project, Project X, and we are delivering a stable version here. So this is the stable version of a project, which is XS. But again, the developers need to test it out as well and give out to people who can test it. Before rolling out a new version, you'll have to test it, right? So we are releasing beta versions of a project as well. So we have a different channel. So this is the stable channel where normal people can get it, and this is the dev channel where developers, other developers, and beta testers can get our software from. And we finally decide that we can create a third stream as well, a third channel as well, where we can call it the XT, the testing channel, where the internal developers can do black box or white box testing on the product that is being developed, and which is the objective, right? To test out changes, to test out new things and everything. So this is the test channel. These are essentially branches of our main project, which are spreading out to three different objectives. One is to create a stable version which will not be fiddled with much. Then we have the dev channel. Dev channel is going to be basically for people to test out and to point out the bugs and issues and everything that is causing the software or the product to not work as it is supposed to do. And third channel is the testing, which is the most extensively worked with channel, where the internal developers are going to push their unstable code every day maybe, and they're going to do a lot of testing here. So how do we do that? We have a project here on the main branch, and we need a dev branch so that other developers can test it out, and we can before releasing a stable version, we can release a dev version so that we can make the final improvements and everything. So the way you create a new branch is you head on to your GitHub, you click on this drop down menu which says main, and then it says that find or create a branch. We can write dev. Since dev branch doesn't already exist, it's going to prompt you that you can create a branch from main. This from main means, like, this is important to understand. From means basically means that it is going to create a new branch which is going to be a copy of your main branch. It is going to create it from main. The current state of main is going to be copied to your dev branch. So let's do that. Create this dev branch, and it's going to have a little box here which says that this branch is even with main, which means that these two branches, dev and main, are essentially equal. You can also look at this from the perspective from the first example, that this is the front end branch and this is the back end branch, and our objective is to merge them into, let's say, a third branch, which is could be anything, but we're not creating the third branch. We're going to keep it simple here. Let's not overcomplicate things, right? So what I'm going to do here, let's just say that there's the second developer with me, Dhoomketu, and he goes on to this main.cpp file and cpp. Okay. Okay. So what he does is he makes changes to the main file, which are also essential for our software to work more efficiently. And he has added this very important line of code which is essential, and he also on his system, let's just say, commits these changes. Now, as you could have guessed that the dev branch, the main.cpp and available in the dev branch, is different than what we have on our main branch. And that's exactly what GitHub is trying to tell us, that this branch is one commit ahead of main, because the other developer Dhoomketu has just pushed the commit, and it is one commit ahead of the main branch. And it's also prompting us that dev had recent pushes less than a minute ago, and it's prompting us to that you can compare these two changes that were made and create a pull request. Before we do that, let's just try to get that dev branch on our physical machine. I'm going to clear out my terminal. If you're on Windows, the command is cls, not clear. Okay, so right now our main.cpp file, which is available on our local machine on the branch main, doesn't have that second cout statement that was created by developer Dhoomketu, because it was on the dev branch and we are on the main branch, as it says here. How do we check, or how do we switch branches? So the command to do that is git branch. It is telling us that we are on the main branch, as it shows a little asterisk there. You can press Ctrl Z here, and to switch branch, the command is git checkout. Now checkout means basically you're checking out from mall, you're checking out from a parking lot, or you're checking out from anywhere, that okay, I am done here, all of my stuff that I want to do is done, and now I'm checking out. So that's exactly what I'm doing. I'm done with the main branch, and I'm going to switch to the new branch which was created as dev, and I'm going to press enter now. And the moment I do it, let's see that there was a new line added to my code, which was the seventh line here, right? And it says that hoo ha he right? So we have switched to the dev branch. I can make changes to the files like I normally would. I can add another cout statement here, and I can say that this is the change made after branch switch, and then I can terminate the statement, and okay, we're good to go, right? I'm going to come back here to my terminal and I'm going to write this command git status scan just to check what's happening in my repository. It says that on branch dev, right? Earlier it said branch main, but after the switch that we made, it says that I'm on branch dev, and it says that your branch is up to date with origin main. Okay, we are even because I have not yet like staged the changes that I have done for the commit, because it says right here, it says it says the file has been modified, um, and it says in bright red colors that changes are not staged for a commit. Okay, that's what we're going to do. We are going to add all the files again. So git add all. Now we have added all the files for the commit. How do we check that? We can use the git status command again. I'm sorry. Now it says that changes to be committed. Your branch is up to date with origin dev. Again, yes, changes to be committed. So let's commit these changes, right? So git commit, and I can add a message. This message is going to be changes to the lib file, and then I'm going to press enter. Then again, if I check git status, oh my god. Okay, so now your branch is ahead of origin dev by one commit, of course, because the changes that I made in the lib.cpp file are not present on the website on github.com, the repository that I actually have here. So this repository that I have on my physical machine is ahead by one commit. How do I make them even? So now I need to upload the code that I have on my physical machine, local machine here, to GitHub. So the command again for that is git push. Just git push. That's how you do it. If I go back here to my GitHub, sorry, and I refresh the page, first thing that you need to notice is this branch is two commits ahead of main. We already know the first commit was made in main.cpp, and the second commit is made in the lib.cpp file, and we have a message here changes to the lib file, and it was made 1 minute ago. That's very nice. But before we actually go and talk about comparing and creating pull requests and everything, we need to talk about pulling the code. We know how to upload the code. What if the changes were made by the other developer here and he pushed his code, and now I need to fetch all that code before I work? So for instance, we can go to lib.cpp file and we can create a third line. I'll just copy this one here and I'll paste it. Not like that. I'll just paste it here. And this is to see how pull command works. Right. So the other developer Dhoomketu, committed these changes, and now it's going to say that it is ahead by 3 commits of main, which is fine. Update.lib.cpp was the commit message, and it is made now. But if we come here in our lib.cpp file on our local machine, we don't have that third cout statement. How do we fetch that code which is available on the website, the most recent and the most stable and the most amazing version of code which is available on the website? How do I get it on my computer? It's very simple. Just like we're pushing the code, uploading the code, we need to download the code by using the command pull. We can pull the code by using git pull and just press enter. It's going to give us an output, and as easy as that, we have the addition of 8th line here. It shows in green color, and it has given us an output. This is to see how pull command works, which is exactly what we did, right? So this is how basically it works. So now we are done with push, we are done with pull, we are done with branches, staging, commits. We have created a repository. Now only thing that we need to talk about is pull request, issues, and pages. Let's go back to our GitHub website and talk about this. Compare and pull request. Now go, if you remember, which most probably you do, I told you guys that obviously you're not going to add collaborators, so many collaborators to your project. They are going to work on their own. So how they are going to work on their own, we'll talk about it by forking this repository, which is very important. But I personally feel that it's a video. We can make a video different video about forking. It deserves a video on its own, a dedicated video. So we'll probably talk about it sometime else. So we can create and compare a pull request between these two branches so that we can like the changes. This is the most stable version of the code in the dev branch. All the developers and the beta testers have told us the issues and we have fixed all of them, and now we are ready to push the code that we have in our main branch to our stable branch so that normal people can use it. How are we going to do that? We are going to go and click on compare and click on pull request. Look at this little dialog box that we have here, this horizontal dialog box. It says that the base with which we are comparing is the main branch, and what we are comparing is the dev branch here, and it is going to check whether you can merge these two files or not. Well, of course you can merge these two files because we have only appended new changes. We have not made changes to the existing code. If we did, it would have shown us that what you want to do, or it would have just like tell you that yes, these files can be merged, there are no clashes. So I can leave a comment. I can just tell it first pull request, and we have created a pull request. And what does pull request essentially mean? Pull request basically means that you are requesting the developers that okay, we have made these changes and you need to pull these fresh new changes before working, because this is the better version of the code. And okay, this is the better version of the code. uh, Now the moment you click on create a pull request, you will be routed to this page called pull requests right here, and it shows one. Then we have one pull request, and now this pull request has three commits onto it. We updated the main.cpp file, and then we made changes to the lib.cpp file, and the final commit was updated the cpp file where we added the final comment to our lib file, which here this is how pull command works, right? We have these three comments. We are absolutely fine with these changes, and we are ready to push these changes to the main branch. What we're going to do, or how we do that, is we simply click on this green button that says merge pull request, and we click on it. It's going to tell us what uh, like message you want to like have, or just like the commit message and just like the pull request message. Can ask you that what is going to be your confirm message. You can write whatever you want to. You can confirm the merge. It's going to merge, and it's going to give you a confirmation that delete request successfully, pull request successfully merged and closed. Now if we go back to our repository and head on to our main and check the lib.cpp file, we have all those three commits that we made in the dev branch, and now they are available in our main branch, and that is how it works. But now see, the true essence, like I was talking about of GitHub, is that a lot of people are going to be working on it, and that is how great software are built, right? So now someone figured out that there is a very grave issue with the project, with the code that we have here, even in the stable version or maybe in the dev branch, whatever. So how do they notify us? They're not going to call me on the phone. They're probably living on the other side of the planet. No, that's not how they're going to do it. They're going to go to the issues section, and they're going to create a new issue here. The title is going to be very, very concise that what exactly is happening. So let's say that I am that developer, third developer, who figured out that there's this issue, this very grave issue, and he's gonna tell me, he's gonna give it a title. So uh, wait, and then he's going to leave a comment where he's going to describe the problem in detail. Always describe the problem in detail, uh, the issue in detail. So he's going to describe the issue in detail. Um, and now he's going to submit the issue. We have a new issue, like just like the pull request, we had a little one here. Now we have an issue here. The issue is currently open because obviously this issue still exists. So let's just say that I'm the developer. I wake up next day and I check my repository, and there's this one issue pending here. I open this issue and I check the details of it. So it says that it doesn't do shit. Delete the repository and quit coding. And I figured out that this is correct. This is not correct. Sorry. So what I'm gonna do now is that, let's just say that I have solved the issue, and then what I'm gonna do is I'm gonna tell him that okay, and then I'm gonna close the issue with this comment. I've done it, and the issue has been closed. It shows it in a bright red color. If I refresh the page, I don't have any open issues again, but I have one closed issue right here, which was solved. Now we know that how issues work, we know how pull requests work, we know how branches work. The final thing that we need or to talk about is the documentation part. You always remember when you're working in open source, or if you're working in anything as like on a project and you're uploading it anywhere, or if you're ever writing any code, always remember that you are obligated to document it. You are supposed to document the project, the current status of your project, and the best way to do it is by adding a README file to your project. A good way to do it is I use this is how I do it. I prefer this method of doing it. We're gonna switch our branch again. Git checkout main. Right. Again, we need to pull the changes that we made. Right. We have pulled our changes, and now our main branch is up to date. Is even with what we have. Like our local machine is even with what we have on our GitHub website. Right. Now, if we go back to my code editor, now I'm in the main branch. It says right here main branch. I'm going to create a new file here, and I'm going to call it in all caps readme.md. And now MD file extension means markdown. It's a it's not a hypertext, but it is a markup language, and it is you can call it a lesser detailed version of HTML, which is the same thing. Both have markup languages, but HTML has a lot of syntactical sugar, and it also has a lot of styling sugar with it. You can structure your pages, but that's not how Markdown works. The developers of Markdown had this philosophy that anything that you are writing in a Markdown file will be displayed on the web page as is. You cannot style it. You don't have to style it. It will be shown just the way you are writing it. We're not going to go over how to write your read markdown file or your readme file, or what is the syntax of markdown file. That's a video again for a different day. But let's just create a very basic markdown file. I'm going to give it a title. I'm documenting the project right now. Maybe I'll add a block code, a quote. Yeah. Yes. Right. Let's just say this is fine for our GitHub project for this little while. Right. Let's commit these changes and push them to the repository. We have successfully pushed the changes to a repository, which is very nice. Now we can come here, we can refresh the page, and you will see that, and all of a sudden we have a new tab opened up here on GitHub, which says that this is a life-saving project. This is made by Anirudh Rath. Now GitHub uses the README file as the front, like as the home page of your project. If we go onto the home page and check out some different README file. So I've opened a random repository here. If I scroll down, look how well structured and detailed these README files are. It says make a web development faster. I don't know what it is. It's some SWC project. I don't have no idea what it does, but they have a very nice structured README file. So if you're new and you're coming to the project's repository for the first time, so it is essentially a guide. It's telling you how you can do that. Now check out the documentation, features, performance, and everything that you might need to get started with this project, this SWC project. But we're not concerned with it, right? We are concerned with our project. Now we have, this is a life-saving project. We have a README. You can structure it properly, whatever way you want to do it. Entirely up to you. And now we are finally on our last topic that I wanted to discuss on this video, at least the pages section. A pages section allows you to create a web page or quickly for your project. There is a prerequisite for using, your this pages thingy, that you need to have a portfolio which or a repository which goes by the name github.dhoomketu.github.io. Only then you can use the pages tab. But if you are aware of it, we'll just like start like I'll just quickly explain it to you. Again, this is something that requires a video of its own, but I'm quickly gonna skim through or skim over it and show you how it works. Now we are in the GitHub Pages section, and it is telling us that your GitHub Pages is currently disabled. How do we enable it? From this drop-down menu, we select the branch that we want to use for our GitHub Pages. Of course, we want to use the main branch because it's the most stable and the best version of a product. Then we're going to click on Save. And the moment we do it, it is going to give me a little confirmation here that your site is ready to be published at http this boonga boonga. What I'm going to do is I'm going to click on enforce https, and I'm going to refresh the page. The moment I do it, it says that your site is published at https://anirudh.dev. Unga boonga. Don't bother how anirudh.dev got here. It's a video, or it's something that is not for this video. At least it's not fit for this video. I'm going to click on this URL, and now my website. Now I have a website, a web page from a project. It says Unga boonga. This is a life-saving project. This is made by Anirudh, which is very nice. My project is already on the web. Now, the interesting thing is, GitHub Pages, the best thing about GitHub Pages, which I personally feel, is that it recognizes a web page file, which is your index.html file if you have any. By default, it uses your README file because it's the only markup file available for GitHub Pages to read and display it on the web. It of course cannot show the contents of lib.cpp and main.cpp on the web, but it can show the contents of README file. So if you go back to our text editor here, and if I add an index.html file, we are essentially providing an index file to our GitHub Pages to read or to display data from. So let's create a basic index.html file here, and I'm gonna give it a title, and the title is gonna be, what is the title gonna be? Right, and in the body, I'm gonna have, let's just quickly get done with it. Right, so now we have index.html file in our project. Let's commit these changes. So I have pushed these changes to my repository. I can go back here to my browser and I can refresh it. Now I have an index.html file. If I go back to settings and go to pages, and it is loading the HTML file here. It says that your site is ready to be published at this. If I refresh it again, I just have to wait for a little while. We can pause the recording until it's done. Okay, yeah, it hardly took any second. So it says now that your site is published at another Unga Boonga dev, whatever. So if I open this in a new tab here, Why is it? Yes. So it is now reading from my HTML file, unga munga hehe, which is very nice. So this is how you can get yourself started with GitHub and put your code online out there for the world to see, um, and for you to store your code properly, because your computer can crash at any time, so you won't lose any of your important projects. Nonetheless, this is it for this video. Thank you so much for watching. I hope you probably learned a thing or two. I'll make a video on SSH, a detailed video on pages, pull requests, and forks, and the other features that we have in GitHub. Probably in the future, I don't know. I just do it because I want to. Anyway, thank you so much for watching. Take care of yourselves, stay safe, and yes.